In this video, we're going to discuss how to use inverse trig functions to solve for an angle, and basically how to do it on a calculator more than anything. But the idea is this, essentially. We can actually use a calculator basically to help us find an angle when we have some sort of triangle set up and we wanted to work backwards to find an angle. So let's say we knew that we had a 10-foot object here and it was casting a 20-foot shadow somehow. Could we find this angle right here? We know it's like less than 45 degrees, but could we actually find this? And the answer is yes, we actually can find this using inverse trig functions, which are these three keys that you see here. So, for example, if I were to grab a calculator, because this is what it's about, to use a calculator to go backwards and find angles, you'll notice here that I don't have that on my calculator, but if I were to shift, you notice that I have sine -1, cosine -1, and tangent -1. And we're going to refer to these as sine inverse, cosine inverse, and tangent inverse, okay? So these are the inverse trig functions, okay? And what they do is they work backwards to find angles. So we'll make ourselves a little note here. Why don't we grab a T here? We say inverse trig functions are angles, essentially, but I want to make sure that I mention that. But inverse trig functions help us to work backwards to find angles. That's what we basically want to know. Okay. So that being said, let's go ahead and start with this example here. We said if sine of theta were equal to 0.8192. Essentially, what we're saying here is this. If the sine of some angle that we don't know this angle right here, gave us this answer right here, could we work backwards to find out what angle the angle theta is? And the nice thing is we can actually do this. So we say the sine of theta equals 0.8192, and I'm just grabbing that from here. What we can do is this. We could say, then therefore, the angle theta is equal to the sine inverse of 0.8192. Okay, and so basically we say the angle here is what we get when we do the undoer of sine inverse to this number over here. Okay, and really all we've done is we've taken the sine inverse of both sides. We say if I take the sine inverse of the left and the sine inverse of the right, what I end up with is the sines canceling out. Now we're not solving trig equations yet, but we're going to use inverse trig functions to help that cancel out, and we're left with just the theta. And on the right, you notice here we have the sine inverse of 0.8192. So in order to figure out what this angle is, which I kind of admit here, I think is 55 degrees is what I've worked through here, I would just get my calculator out and I would say, look, I've already got the answer. The answer is 0.8192 on this trig ratio. Now if I were to do the sine inverse, the reason why I'm doing sine inverse, by the way, is to undo sine. We would do cosine inverse to say undo cosine, and tangent inverse to undo tangent. We're doing sine inverse here, and you notice I get about 55.04004. Okay, so what we've just found is an angle. So we're just going to go out to usually just like one decimal place or nothing. So 55.0 degrees or 55 degrees. Okay, and we can always check this again. What if I were to take the sine of 55 degrees? So 55, I take the sine of it, and you'll notice here that I get something really close to what I started with. Okay, so that must have been our angle there. We can always check that by substituting it back into the original equation. Look, if I put a 55 right here, I did get the about 0.8192 back. So why is this nifty? Well, this is nifty because we're going to be solving trig equations. Okay, so here's how this is going to work. We're going to solve for the angle. Solve for angles. And if that's the case, we're going to have to lay out a few steps in a process here. So we say solve for angles. Let's start with this. Step number one is going to be always this. We're going to isolate the trig function of the unknown angle on one side of the equation. Okay, that's what we want to do first, is isolate that. Let's do this. There we go. On one side of the equation. Okay, and then what we're going to do is use an inverse trig function to quote-unquote undo the current function. This should leave the angle isolated, basically. Leave the angle isolated. And so it's a nifty way to solve equations. As a matter of fact, we're going to do that right now. using these three steps. So number 1 up here, number 20 actually, you see it here. It says cosine of some angle I don't know is equal to this answer here. What I want to point out here is, first of all, cosine is by itself. It's by itself on the left side. So now we're going to undo this, and we're going to undo cosine using the inverse trig function to cosine, which is cosine inverse. So we're going to do cosine inverse of the left side of this equation equals cosine inverse of everything on the right. We want to make sure that when we're writing this cosine inverse, we're saying cosine inverse of the left-hand side. Everything goes in there. And we have cosine inverse of everything that used to be on the right-hand side of this equation, these things here. And so these things cancel out, showing our work there. We get theta equals cosine inverse of 0.9744. So really we're trying to ask this question, what did we take the cosine of to get this answer? Our calculator is the one thing that's going to do the work for us here. So we say, okay, we had 0.9744. We want to take the cosine inverse of this. So cosine inverse, we get about 12.99. I'm going to call this approximately 13 degrees. Okay, and we're going to fly through these other ones here, but basically you'll notice here again, I've got tangent by itself, so we'll take the tangent inverse of tangent of theta on the left, and we'll take the tangent inverse, this equals, of 2.4751. Okay, and so again, on the calculator, we have this. We have tangent inverse of 2.4751. We want the tangent inverse, so we get about a 68 degree angle. So we say theta is left by itself, and it's approximately 68 degrees. So finishing up these last ones here, basically really quickly I want to kind of blow through this. Remember again, you have to get the trig function by itself. So this equation here, we would want to first start by eliminating the 3. So we say sine of theta is equal to 1.2202 divided by 3. Okay, and again, the quicker you get at these, you know, we say about 0.40673 repeating. You know, the quicker you get at these, you say, well, I know that I'm going to do the sine inverse now. So theta is equal to basically the sine inverse of this. We can now just pull out our calculator and say, look, I know I'm going to do the sine inverse to undo the sine. So about 24 degrees on this angle here. Okay, and again over here we would divide by 4. This one's actually got another step built in. We'd say, well, let's get our calculator. On the right side, it looks like we have 0.4240 divided by 4. So 0.106. So now we have this. Cosine squared of an angle is equal to 0.106. Now we need to undo the squared. We have to isolate the trig function first. So we're going to take the square root of both sides. And so now we have just left cosine of theta is equal to the square root of this number. We're going to take the square root of this. So here's our square root. And so now I have the cosine of theta equals this number. And honestly, see, I'm getting quicker at this. We say to undo the cosine and leave behind the angle. We need to undo this. We'll just do cosine inverse of both sides. So we get theta, and we'll do the cosine inverse of the right. We get cosine inverse of the square root of 0.106, which we already calculated on the calculator to be this number here. We need to do the cosine inverse of this. So we get about 70.99. So theta here is approximately 71 degrees. And then last but not least, this bonus one here, it just kind of tends to throw people that we have sines on both sides. But keep in mind we're solving for theta, which means first, let's get the sine of theta by itself, which means we'll divide by 5. The nice thing about this equation here is that on the right side, you say, well, what do I do with the sine of 54? Since we know the angle is 54, we can actually just go ahead and evaluate this right side on a calculator. That is, we could say, well, let's find the sine of 54. The sine of 54 is this. We'll divide it by 5. So this number right here equals the sine of theta. Sine of theta is about 0.1618. Now we'll do the sine inverse. So sine is about 0.1618. We'll do the sine inverse of both sides. Sine inverse of both sides of this equation. And we kick those out, we get left with theta equals the sine inverse of this. We just need to ask the calculator now. We shouldn't technically round to the last step, so we say sine inverse. And we get about 9.3 degrees. So I'm actually going to leave that one with the decimal in this one. 9.3 degrees. And these are all easy to check by plugging back in.